stroke volume is the difference between the end diastolic volume and the end systolic volume. So again, the heart's the most filled with blood at the end of diastole, so the left ventricle is filled up all the way to here, right? So that's the maximally filled with blood before the ventricles contract, right? That's why the atrium shove the blood into the ventricles, AV valves close behind it. Now we're pushing blood out, blood is ejected, and our blood level goes from here down to here, right? Just generic lines. This difference here, that was the amount of blood that left the heart, right? Not all the blood leaves the heart. We'll talk about ejection fraction, but a certain percentage of the blood is going to leave. So that's how we calculate it. So we take end diastolic minus your end systolic. So we could use an example here. Say my stroke volume. Let's say my end diastolic volume is 120, and my end systolic volume, let's say, is 50. These are both in milliliters. Well, then my stroke volume would be 70 milliliters. Okay, so how can we increase stroke volume? Well, two basic ways. One, we increase our preload. So if we shove more blood in here, if we start with a higher EDV, right? So if we get more blood returning back to the heart, right? More venous return, increasing that preload and the stretch in the heart and shoving blood in there, that's going to raise our EDV. If we raise our EDV, then as long as the heart's contracting properly and healthy enough, we're going to have a higher stroke volume. Okay, so increased preload will increase my EDV and ideally increase my stroke volume, which then is going to increase my cardiac output, right? So that's how preload and like the Starling laws work. You shove more blood in the heart, it stretches more, it's like filling with more blood, it's going to eject more blood. That's the theory, and that works to a point. Okay, so that's how you get stroke volume. So one way is increasing your EDV. The other thing we can do is increase contractility. So if we have the same EDV in two different hearts, but one heart squeezes way harder, right? Way harder, that's called contractility. So say there's two different hearts that have 120 milliliters of blood in them. One has more sympathetic outflow to it, so it's really squeezing hard. And the other one's just kind of, I'm not going to squeeze that hard. Well, increasing the contractility, so if you have the same EDV of 120 milliliters, the harder you squeeze that, the more blood's going to leave. So the two things that can really affect how much stroke volume we have isn't just, oh yeah, contractility, the heart will squeeze harder. Those positive, we call ionotropic effects from the sympathetic nervous system. Yeah, that'll make the heart squeeze harder and push a little more blood out. But if we don't have the blood to begin with, there's no blood to push out. So increasing my EDV from getting blood back to the heart is going to help. And then contractility is going to help take whatever EDV you have and squeeze it harder to push it out. Hopefully that makes sense. Now, ejection fraction. So this is where you're really going to clinically, look at these, the value you're going to look at for heart function. Someone gets an echocardiogram, and you'll say, what's their EF? What's their EF? So their ejection fraction. So ejection fraction, this is how you calculate this. You look at their stroke volume over their EDV, and you multiply it by 100, which gives you a percentage because it's an ejection fraction, but we say it in percentage fraction. Just same thing.